Welcome to StrategyGrid.AI Learning Series. In today's session, we will focus on one of the most useful but least professionally managed feature in modern AI tools, and that feature is memory. A lot of people now notice that tools like ChatGPT, Claude, and Gemini seem more personalized than they used to be. That is because these systems are no longer operating only as a one-off prompt and response tools. They increasingly carry context forward, whether through saved memory, recalled chat history, or project level continuity. That makes AI more convenient, but it also changes the risk profile. The issue is not only whether the model is accurate, but the issue now is whether it is using the right context for the current task. The main idea is simple. AI memory can be powerful when it is deliberately managed and dangerous when it is allowed to operate invisibly in professional work. When many people hear the word memory, they imagine a clean notebook of facts that the AI stores accurately and retrieves neatly. In practice, it is more complicated than that. Across current tools, memory can refer to at least three things: information you explicitly ask the system to remember, patterns inferred from repeated interactions, and the ability to pull relevant details from past chats. Modern AI systems now remember past interactions, adapt to current user behavior, and reuse prior context when generating responses. For example, ChatGPT stores user preferences and references past chats. Claude maintains conversational context within sessions, while Gemini integrates across tools and past interactions. This means AI has shifted from being a stateless tool to an adaptive system that carries context forward. As you can see, in each of these tools now you have the explicit mechanism to set your memory needs, whether in Claude, ChatGPT, or Gemini. When it comes to memory, there are two features one needs to understand as a professional using AI. These are saved memory and chat referencing. These are two related but distinct features. The first, saved memory. This is the information that persists across conversations. It can include preferences, writing style, recurring tags, or other details the system has retained or inferred. The second is chat referencing, which is the system's ability to look back at prior conversations and bring relevant context into the current answer. That distinction between saved memory and chat referencing is important because users often treat them as the same thing, but they create different kinds of risks. Saved memory can create long-term contamination if the wrong thing is retained. Chat referencing, on the other hand, can create short-term drift if the wrong prior conversation is pulled into the current task. This distinction also matches how the major platforms now describe their tools. OpenAI separates saved memories from chat history references. So you have the capability within, for example, ChatGPT to only use saved memory or chat referencing or both. Claude explicitly describes searching and referencing past chats, while Gemini distinguishes saved information and instructions from the use of past chats for personalization. So the practical lesson is this: when the AI sounds personalized, you need to ask yourself whether the personalization is coming from a remembered preference, retrieved chat, or both, because that gives you context on how you need to look at the output from the system. It is important to acknowledge why these features are genuinely valuable. When used correctly, memory and chat referencing can significantly improve productivity. And this is done in several ways. One, these features reduce repetition. You do not need to keep restating your preferences, your role, your formatting style, or recurring tasks every time you want to use these tools. The second is that they improve continuity. Long running work becomes easier because the tool can pick up from where you left off. The third one is that they increase efficiency. Instead of rebuilding context every time, the AI can start from a more informed position. And lastly, they often improve perceived intelligence. When a tool remembers your style, prior goals, it feels less mechanical and more useful. This is especially powerful in professional settings involving repeated workflows, report drafting, teaching preparation, meeting support, content refinement, project planning, or multi-step analysis. One thing about AI capability is that value comes not only from the model itself, but how effectively context is carried across a workflow. Memory helps with that. The problem is that the same mechanism that creates convenience can also create hidden errors. As such, it is about balanced judgment. Memory is operationally useful, but only when its boundaries are adequately controlled. So here is the problem and hidden risks. AI systems do not naturally separate your work into neat human-styled folders of meaning. They work through association, similarity, and pattern reuse. That means prior context can bleed into the current text even when it should not. A phrase, theme, or concept from an earlier conversation can become active again simply because it looks related to the new prompt. That is why I use the phrase associative amplifier. These systems often do not filter context the way a careful human professional will do. They amplify signals that appear relevant. The example here illustrates this well. If you were previously discussing cloud infrastructure and later asked for help on team resource allocation, the system may carry over technical language because it detects lexical similarities around resources, capacity, or scaling. The output may still sound polished, but it is now misaligned. This is not classic hallucination in the narrow sense of invented facts. It is contextual bleed, the wrong prior frame shaping the right current text. The distinction is important because many users only watch for factual falsehoods. They do not watch for contextual misfit. In professional work, that can be just as damaging as hallucination. There are four common failure modes that professionals should be aware of. The first is contextual bleeding. Something from one project shows up in another and pollutes the output. The second is false relevance. The AI treats two similar looking situations as the same, even when the meaning is different. The third is memory contamination. Outdated, weak, or irrelevant information remains in the system's active understanding and keeps resurfacing. The fourth is cognitive lock in. Because the system is anchored in prior context, it becomes less flexible. It keeps returning to old framings instead of helping you think freshly. These failure modes matter because they are subtle. The response may still look fluent, structured, and persuasive. The danger is not always an obvious error. The danger is hidden misdirection. This is why professionals need a better standard than the answer sounds good. A more useful standard to evaluate is determining if the answer is grounded in the correct context for the correct task at the correct time. This is especially important in analytical work, writing, strategy, teaching, and decision support, areas where relevance and framing matter as much as factual correctness. If the wrong assumption enters a task, analysis quality drops. If prior context quietly biases the output, decision making can become distorted. If users rely too heavily on continuity, they may stop noticing when the model is recycling stale frames. There is also a creativity cost. Sometimes you do not want continuity. Sometimes you need independent reasoning, a fresh start, or a reframing of the problem. This is why memory needs to be managed at the level of workflow design, not just settings. This professional question is not, does the tool have memory? The better question is, in this task, do I want continuity or independence? That is the key decision users should make before prompting. Once you start thinking that way, memory stops being magical and becomes something you actively control. And control this behavior by explicitly managing context. Here are 4 approaches that can be used. The clean mode mechanism. This is the one you use for new tasks. You deliberately tell the system to ignore prior contexts and treat the task as a fresh new context. We also have the scoped mode, which is used for ongoing tasks. You want continuity, but only within the current project or stream of work. Next one is controlled context. This is where you implement precision work. You explicitly provide the context the system may use and nothing beyond that context. Then you have the reset mode, which is used for recovery. When the AI has drifted or brought in the wrong frame, you stop it, clear the direction, and restate the stacks. This is one of the most important habits professionals can develop. Prompt for context control, not just content generation. Current product design increasingly supports this logic. OpenAI now distinguishes saved memory, chat history references, temporal chat, and even project-only memory for contained work. Claude allows past chat search to be tuned off and limits project searches to the specific project, while Gemini also allows memory control and temporary chat for conversations you do not want remembered. So the practical takeaway is that memory management is not only about settings, it is also about language. The user must actively signal whether continuity is wanted, bounded, or inappropriate. The final message is simple. Humans usually separate tasks by intent, relevance, and context. AI systems often retrieve by similarity, pattern, and association. That means good AI use requires more than writing better prompts. It requires managing when the system should remember, when it should forget, and when it should be constrained to a defined context. So before using AI on any meaningful task, ask a simple question. Do I want continuity or do I need a clean slate? If you ask that question consistently, you will avoid a large share of invisible memory related errors. The broader lesson is not that memory is bad. The lesson is that memory is powerful, and power without context discipline creates risks. That is the mindset every professional using AI must have. Use AI memory deliberately. Verify when it helps and intervene when it starts shaping the task in the wrong way.